Hello everyone, welcome to my channel Learn with Titonsa. Today in this video I am going to discuss about the various operators and how to take input and output, how to produce the output in C programming. Okay, various operators which we are going to use. Earlier I have discussed what is operators. Here I am going to discuss about the types of operators and how to use them. Okay, and how to take input, static program and dynamic program. Here we will see both the type of programs, static as well as dynamic. Static program is where values will be given before the execution. Okay, before we start executing the program, values will be given, and dynamic means while execution it will take the input from the user. Okay, so let's continue with the operators in C. Okay, so operator, already I told you what is operator. Indicates an operation to be performed on data values which yields a new value. Means when we will carry out a particular operation, it will produce a new output. Okay, new value. Well, say suppose 2 plus 3. If we execute here, the operator is plus. Okay, so 2 plus 3, data value 2 and 3, these are operands. When we will execute 2 plus 3, it will produce 5. So new value. Okay, so here let's see the types of operators, comma and conditional operator. Each of these operators we will see practically in the next video. Okay, here just I am giving you the introduction about the operators, various types of operators. In the next video we will see the various types of operators, examples. Here also we might see. Let's see. So comma and conditional operator. Then we have comma operators. That means we'll see in the print statement when we make separation between different values, different variables, identifiers types, we use comma. Conditional operator. Here we have one condition, then we have two values, true and false. We'll see practically, okay, afterwards. Arithmetic operators. In arithmetic operators, we have unary operator as well as binary operator. Unary means it will work based on a single operand. Okay. For example, a equals to minus 10. Here you can see. Binary means by means 2. So here operator needs two operands. Okay. Binary operator works on two operands. Ternary operator is almost same as conditional one. We'll see later on. Relational operators means comparing. We need to compare, say whether this particular value is greater, smaller, either greater or equals to, or is the value is equals to, suppose the value of a is equals to c or not, checking. Okay, then whether the value of a is either greater than c or equals to c. Okay, all those things. Okay, and not equal signs. Not equals to means it is not equals, the value of a is not equals to c. It may be greater, it may be smaller, but it should not be equals to c. For all those types we use relational operator. Okay, then assignment operators. Here actually assignment operator means we'll perform the operation as well as we'll store the new value. Okay, just for example, if I write a equals to a plus 10. Okay, so suppose the value of a is 10, so the new value of a, it will be 20. So this one, in place of writing this, we'll write it like this: a plus equals to 10, which means a equals to a plus 10. So the initial value of a is 10, so here 10 plus 10 will be 20, so a will hold 20 here. Okay, this is assignment operator. Plus equals to, minus equals to, subtraction, then the new value will be stored in the particular variable. Okay, we'll see practically. Logical operator, the and. Okay, and operators, or operator, not operator. And operator when we need to use, whenever we need to check two conditions, and if both the condition is true, then only the output will be true. Okay, otherwise it will be false. In case of or operator, either of the side, the or operator, left side and right side, if left side is true, it will produce true. If left side is false, it will check right side, and if right side is true, it will produce true. Okay, either of the side must be true. The only difference between and or is that in and operator, both the sides, left side and right side, must be true. Then only it will produce true. Just for one example, suppose 2 less than 3 and operator 3 greater than 2. Here you see both the condition, 2 is less than 3 and 3 is greater than 2. Both the condition, both the left side as well as right side. This one is left side, this one is right side. Both the sides are true, so it will produce true. Okay, it will produce true or 1. Okay, In case of for operator, either of the side must be true. Okay, we'll see afterwards. Bitwise operator, shifting the values. Okay, this also we'll see practical implementation of all these operators in the upcoming videos. Okay, so here you see a basic and simple program, initializing, declaration. Here many things are there actually. A simple program, simple static program. This one is a static program, simple, and here you can see the output also. So first, as I talked about the various header files, you can see here conio.h, console input output. Okay, for in the console, for output, for input purpose, for output purpose, stability, all those purpose we use console. See, get ch. For get ch we need to use console conio.h. Okay, here this program I have written in turbo c compiler. Okay, if you are using turbo c compiler, then only you can write like this. Otherwise there are certain other syntaxes are also there for writing the programs. Before void main you need to write using namespace, std, and all those things. These things also you can see online. I'll show you online on some online compilers, or say dev c++, in the ball and c. In all those compilers you need to write a little bit different syntax, or maybe header, in the header file also little bit changes will be there. But this one I have written according to the turbo c compiler. Okay, stdio.h. See here conio stdio.h means standard input output. Okay, for this printf, statements we need to use stdio.h. Okay, how this will work? Here we have to write stdio.h, because this, how this function will work, this working principle means the definition of the function of those functions are written in stdio.h. Okay, now here you can see int a. Here I have declared a variable int a. Here in the structure, in the my first video you have seen, or the second video you have seen the structure of the C program. I had written global variable, but here I have not written any global variable. Okay, whatever is compulsory, header file and void main part. The rest of the parts are not compulsory. User defined functions you will write. If you want, if you require any function, then you will write. Otherwise you can skip. Global declaration also same. If you need to declare any variable globally or any function globally, then only you will use. Otherwise you can skip. Okay, so int a, I have taken a variable integer a as a variable, or you can call it as an identifier also, and this type is integer. That means it can hold integer type of value. It can be negative, it can be positive, there is no problem. Means integer means whole number. Okay, then float b, fractional number. Okay, then here I have used one character c. Okay, that means character value it will take. So here you can see these are called declaration of the variable. Okay, declaration. Okay, these are called, all these variables I have declared here, and these are assignment, or you can say initialization. Okay, initialization, or you can say assignment. Assignment of values. Okay, assignment of values. Fine. So here I have executed. This one will produce this output, this will produce this output, and this will produce this output. Here you see I have written b, capital B. Now, but here you see variable is small v, but this portion I have written within quotation. So within quotation we can write anything. We can write capital letter, small letter, there will be no problem. That's why I have written here capital B, to make you understand that here within quotation we can write anyways. This is comma operator. Okay, separation between the data value and the variable. Okay, now here you can see percentage d. What is percentage d? What is percentage f? What is, these are the identifiers. Okay, that means data types. With this one we meant about percentage d means for integers. For printing integer we use percentage d. While you will take input we will use percentage d. For float we use f. Okay, percentage f. We can use lf also. For long double, we can use lf, as well as g also we can use percentage g also we can use. Okay, now for character we use percentage c. Is that clear everyone? So these this one you need to remember for percentage d and all those things. This one I'll give in the description of this video. I'll put so that you can get some idea from this one. Okay, which identifier you need to use on when you need to use which one. Okay, let's see this one. Earlier this program we have seen. Now this one is actually static program. This one is static. Why it is static? Because whenever we'll execute, we'll get the same output. This one always we'll get this output. Whenever we'll execute this program, we'll always get this output only. Now here I have written this dynamic one. Okay, here I have written dynamic one. So conio.h, stdio.h, void main as it is, int a, float b. Okay, here I have taken two variables. So print enter value for a, you can see printf. Okay, enter value for a. Here colon is not mandatory, but this inverted quote is mandatory. See all the statements end with semicolon. Now scanf. See here one operator I have used, this one called ampersand. Okay, ampersand. This means we are initializing a memory to that corresponding variable a. We are initializing memory. We are assigning memory to this particular variable a. That means in our computer memory we are going to reserve a particular space for the variable a, and in which we are giving the value. So suppose 10, we can give any values, integer values. So whenever we need to take input, you must remember you have to give this ampersand symbol, because here we are going to assign some memory space, okay, to that particular variable. Everything in computer memory, whatever we store, everything gets stored in the memory location. So memory location is important here. So that's why we have to use here ampersand. That means it will assign a particular memory to that corresponding variable a. Okay, b, same thing. Now for enter value for b, here I have given, you see, slash n. This means new line. Okay, this means new line. It is same for C++ as well as Java as well as Python. This is same everywhere. It is same, slash n. Okay, so for float values we take f, and you must remember in case of scanf, here you do not write any message. Here only you have to write that particular identifier, that is percentage f, percentage d, percentage g, c, or whatever s. Okay, so values here I have given one slash n. That means after values the outputs will come in the next line. So same thing here, whatever values you will take, it will be printed like this, and this one also same, b equals to percentage f b. Okay, so this one we have seen here. Let's see some other examples, some other ways how to take input, some other formats. What is the use of this slash, and if we do not use, how the output will be produced. Let's see all those things in the Turbo C compiler. Okay, everyone, let's continue with the Turbo C. Okay, so let's continue with the Turbo C compiler. Okay, so first we need to write the header file. So hash include conio.h. Okay, conio.h, then hash include stdio.h, then we'll write void main. Now you can put this second bracket here, as well as you can put it here also, there will be no problem. So int a, in place of a you can take anything, then semicolon, then float b. I can take in the same line also or in the different line also, there is no problem. Okay, then let's see how to take the input. Simple one. If I do not give a message here, what will be the problem? Let me show you. Scanf. This simple one, with this one I am showing you. Printf percentage d a. While printing, we don't need to use this ampersand, because here we are printing the value of that variable. We are accessing the variable only. We are not going to access the memory location. Okay. So here you see one simple one. Let me show you up to this. Let me save the file. let me say this one. Let me give p2.c c program. As I said earlier, that extension of C program is .c. Okay, so .c. Let's compile it. Let me see if there are any error. No, no error. Let me run the program. Now you see. Okay, fine. 4. Okay, so here before executing this program, let me add one clear screen function. CLR SCR. Okay, clear screen function. Here I have used one clear screen. This will clear my previous outputs from the screen. Whatever output I had earlier, it will be cleared from the screen. Okay, it will be cleared from the screen. So let's compile the program once again. No error. Let's run, execute. You see, that's my screen is empty. Now what to do? How user will understand that here I need to enter a value. Okay, so as I have done this program, I have written the program, so I know that I need to give a value here. So we are getting 40 now. 40 40. What is 40 40? We might get confused, user might get confused. So for that purpose, we should always give a proper message. Okay, so what is the proper message? Here I have to write printf. Okay, enter value for a. Okay, enter value for a. Now you see, if I execute, we are getting a message, enter value for a. Now by this message, we will understand that I have to enter a value. Value can be anything. 100. Again 100. What is 100? Now for that purpose also, we need to give a proper message. Here we can write a equals to. Okay, before percentage d, you can write a equals to. So that if you run the program, now you see I am giving 20. Now I am getting a equals to 20. Now we can understand that we have to enter the value for a, and the second line is giving me the output, that is the value of a is 20. Is that clear, everyone? I hope it is clear. So this is how we can take the input, integer input. Same way we can take the input for float also. So here we have seen for a. Okay, let me take input for b also. Okay, here let me copy this to line. Alt E, Control C. Control C will not work. You must remember here. You can see the shortcut. So I am doing copy paste. Okay, enter value for B. Here I need to take input for B. Here I am taking it as B. Now here I need to change percentage D to F. Okay. Now here I can write printf. Then B equals to, right? B equals to percentage. Which one? F. Okay. Then quotation, comma. Here I can write B. Fine. Yes. So for B, for A I'm giving 20. For B I'm giving 2.34. Now see the values. Now see here, the value of B and A both are in the same line. Okay, and there is no gap. See, after 2.34, then 400, then A. This A is close to it, 34000. Okay, so what we need to do for that purpose, whenever we need to execute a print statement, just before this one, we need to write an /n. /n means new line. Here also you can add, there is no problem. Everywhere you can add this one, there is no problem. Actually, wherever it is required, you can add. Otherwise, you can skip. Now, before this one, if I do not add, then also it is fine. See, okay. See, I am getting this in different line. Now, before B, before that print statement, here also if I add, then there will be a gap between the input and output. Okay. See here. Let me take different values. Okay. Now you see there is a gap between input and outputs. Okay, I believe you understood the use of /n. It will put a new line. Okay, vertical line. It will put a vertical line. Now here you can see after 6 7 there are 4 zeros. 4 zeros have been added. Why? Because of the float. It's decimal precision. Okay, Because of that precision, we are getting this one. Now it totally depends on you how many digits after decimal, how many digits you want to print. So see, just one example you see here, 0.2f, okay, to 2.3 I am writing. Now here I am getting 2.30. Why only 2.30? Because I have written here in this place, you can see I have written 0.2f. 0.2f means after decimal, after point, there will be two places only. Okay, that's why I have given only 2.3, I am getting 2.0. If I give 2.56 or 2.34, 2.11, I'll get directly 2.11. I'll not get all those zeros. Is that clear, everyone? Now let's see one simple. Here you can see the use of comma operator. Okay, comma you can see. Let me show you simple addition. Okay,